I guess I should. Welcome to the November CPC event. Great to see you all. And it's my pleasure to introduce Professor Hakhamanesh Zangeneh, who I've known since grad school at UC Irvine with David Smith. And I remember talking about the crisis of European sciences at a party in Laguna Beach 25 years ago or something. And Professor Zangen has gone on to study with some very esteemed Heidegger scholars and other phenomenologists. And today he'll be presenting on uh, large language models and Husserl, I think, broadly speaking. So please join me in welcoming Professor Zangen.
Thank you for the introduction. I'm going to share my screen here. So I am, there we go. So now everyone should see just the slide. You all see just the slide? Good. Okay, so my presentation today is generally about Husserl and AI. I'm going to narrow that down in a second. I'm going to pick up on one design feature of these things and a couple of engineering results that I've read about in papers from computer scientists, teams of computer scientists working on this stuff. And I'm going to connect that stuff to phenomenology. I'm going to be talking about Husserl, or at least referring to Husserl in all this. I think Husserl is important for this discussion because Husserl is a phenomenologist who writes both about cognition and about this sort of micro level of analysis, but also about culture and about society and about history. And he connects these two levels of analysis. And in that respect, I think he's very useful for what we're going through right now. So the Husserl that I'm interested in is Husserl's Crisis, sections 9a through L. That's the place where he presents his critique of mathematization, which I'll refer to as MC from here on, because mathematization has too many syllables for me to pronounce each time. I'm going to be relying on Jeff to report Husserl's position, an article he published in 2007. I'm not going to debate or dispute anything Jeff says. I'm going to rely on Jeff to report Husserl's position, and I'm going to try to suggest a small addition. Okay, so that's the Husserl I'm going to limit myself to. I can't, of course, do a large-scale interpretation of all of Husserl's works, right? I'm drawing on Crisis, which is a book that has been in circulation, like Jeff said, since I was an undergrad. It's very well-known material. And so I'm going to spend most of my time talking about these features and large language models that I'm interested in. And I'm going to rely on some kind of background knowledge of Husserl on everybody's part. Hopefully that was the right strategy to take. So, these large language models have influenced all of our lives. If you have any kind of a teaching position, students have been using this stuff to write their papers. I'm in the middle of grading right now. Again, I have a bunch of students whose papers were written by ChatGPT. Okay? So this is forcing us to rethink how we assign papers and how we teach our classes. That's a cultural phenomenon. Right? And of course, these sort of micro level features are phenomenologically interesting. And I think through Husserl, we can kind of maybe connect these two things. Okay. So within AI, I'm only interested in talking about large language models, and I would actually suggest that we separate the terminology, right, and reserve the term AI for classical symbolic AI projects, which I'm not going to be talking about. I think that keeping the terminology tight helps us prevent smuggling in various kinds of metaphysical issues. A large language model is basically a neural network that is programmed to take some text input and produce some text as output. The magic is what happens in between the two, but that's the design of the program, right? Any inferences we make beyond the language output is on us. The program is just designed to produce text as output based on a text as input. So I think that I'm trying to shift the discussion from debates about modeling mind to analyses of how we model language. So a few basic ideas about, large language models. So a large language model is not based on pre-given rules, right? So ChatGPT is not programmed with the rules of English grammar beforehand, right? So it does not go from universals to particulars. Instead, it tries to derive rules from the data set that it's supplied with. You could say that it generalizes universals in the form of weights from particulars, which are its data set. So here's a very basic illustration taken from a textbook by Francois Chollet, Deep Learning with Python. It's a basic sketch of a simplified two-layer model during the training phase. Let me get the pointer here. So you see that at the top, you have some input. You have some text that you enter into the system. That text is accompanied by what you expect to come out of the model. He's calling it your target, right? So you hold your target off to the side, you input your text is processed mathematically in a way I'll describe in a second. It's weighted and passed through a layer of calculations and then another layer, another set of weights, and eventually, after your last layer, it produces some output. You then compare that output to your expectation. You calculate the difference as a loss, and then based on that loss, you go back and adjust these weights. And then you cycle through again. And then you have a new output, y double prime, and you measure again, and you keep cycling through this loop until you bring that loss to something that's acceptable to you. And then when you stop, the goal that you have are these weights that you have trained on the input data and adjusted in light of the target that you wanted to get to. Okay? So this is basically a feedback loop, right? The way it's implemented with all the technical details ends up getting the name backpropagation. We don't need to go into all of that detail for this presentation, right? But this is basically the kind of structure that I'm interested in thinking about. Okay, so these models and Husserl's MC. A basic feature of LLMs to consider in light of the mathematization critique is in their fundamental manner of working on language, right? How do they work on language? So they work on language by using what is called a vector embedding. Vector embedding is a procedure for language processing. I'm mostly going to be reporting on this algorithm called word2vec that was published by people at Google in 2013. Right? The way that the transformer architecture does this is slightly different, but I think conceptually it's the same process. Right? The math doesn't change. There's a basic difference in that these algorithms, word2vec and glove, create a store of vectors which you can then draw on, but in a transformer, you create this embedding in the first layer right away. Okay? So an LLM translates language into a vector embedding. So what's a vector? A vector, if you remember your undergrad math, in just two dimensions, is just an ordered pair, a pair of coordinates x and y. In physics, you say a vector is a mathematical object that has a magnitude and a direction. Okay? Now you can write these vectors with an arbitrary number of dimensions, right? X and y, and z. If you do the physics of gravity, you have 3 space and 1 time coordinates, so you have 4 dimensions. A vector embedding that you use in natural language processing is liable to have 500 or 1,000 or even many more dimensions. Okay, what does that mean to have a vector with 500 dimensions? Right? That's nothing that I can intuitively imagine. Why do I need 500 or 1,000 dimensions? So here's a picture of what a vector embedding might end up looking like. I didn't calculate this, right? This is just heuristic. So this is what a vector embedding might look like for just a vocabulary of 4 words: cat, dog, banana, and truck. right? Similar or related words are kind of grouped together. You should be seeing that cat and dog are closer together in space than either of them is to truck, right? Dissimilar words are distanced. And these red arrows are the vectors which replace the meanings of these words, okay? Now, of course, in 2 dimensions, you might say the meanings of these words are very poorly grasped by just a 2-dimensional distance between these arrows. And you'd be right? Language and linguistic meaning has a lot more to it that can be represented in more than 2 dimensions. And that's why you need these vectors to have, 500 or 1,000 dimensions, right? The gambit is, if we just add more dimensions, we will be able to grasp more of the nuances of meaning. So a vector embedding translates meaning mathematically into a high-dimensional space. And interestingly enough, it's not related to the mathematization, but it's a weird thing, I think, for a philosopher. It models meaning based on syntactical similarities, right? It's deriving meaning space from syntactical patterns. The way you create this space, the way you create that vector embedding is you parse a very large number of sentences. Then you look for sentences that are word for word identical except for one word, right? So you might take a sentence like, my dog has 2 eyes. Then you look for other instances of, my dog has 2 blank. And all the words that go into that blank are brought together in space in similar coordinates as the word eyes. And the words that don't fit in there are moved further away. So this process, astonishingly, is able to grasp meaning geometrically. And not only that, a very strange consequence of it is that it allows us to translate analogical inferences into arithmetic on vectors. So an analogy, right? So this is lifted straight from the 2013 paper. The analogy, king is to queen as man is to woman, can be replaced by this arithmetical operation. You take the king vector, you subtract the man vector, you add the woman vector, and the resulting vector, astonishingly, points right to the word queen in your space. So, what does a vector embedding do? Again, you parse a gigantic amount of sentences, you turn language into a space of very high number of dimensions, and then you can replace meaning by arithmetic, or so it seems. But if that's taking place, that means that mathematization is quite successful. And so if this is how the language model is dealing with language by design, it seems that mathematization is intrinsically part of the framework of natural language processing. Okay. So that's the first feature I wanted to bring into the context of the mathematization critique. Now I'm going to move to 2 engineering results. In the title I supplied, I mentioned neural scaling laws. So the discussion of scaling laws goes back to this paper from 2020, which is from people who were at the time at AI. Scaling is a key property of these current models. There have been other papers, but the discussion kind of goes back to this from 2020 by Kaplan et al. In this paper and the next one, there are empirical observations, there's a mathematical framework, and I'm not going to dispute any of that, right? I'm not going to say I have some other observations that I've measured or that I find some other fit than the one they've proposed, right? I'm taking their observation and their explanation at face value and just drawing some implications. So these 3 graphs present the neural scaling laws. Okay. So just by visual inspection, you can see that they're graphing 3 quantities on the horizontal axis against the test loss on the vertical axis. And for each graph, as I move to the right, the vertical quantity just drops. So as I increase each one of these variables and I go to the right, this line just slopes downward in a nice straight line. Okay? So that's astonishing in and of itself. The blue, if you can look closely, I don't know how the zoom shows up on your screen, but the blue are the observed data points. The dashed line and the black line is the fit to the data points. And the fit is astonishingly close. And its predictions are confirmed. Right? So what does this mean? This means that as I grow my language model and the amount of computation, the size of the data set that I'm processing, and the number of weights that are in my network, I can arbitrarily decrease the loss. Okay? Now, one thing to notice is these graphs are on a logarithmic scale, a log-log scale, as opposed to a linear scale. So the equation for that line is not a y equals mx plus b, right? It's more like a constant times by x to some power. They're called, these kinds of equations are called power laws, right? But very simple mathematical expressions, right? Why is it that the improvement behaves so simply? Why isn't it some kind of very complex mathematical expression? Why is the behavior a smooth, straight line? So the implication that I want to draw from that, right, is obvious. You can improve a language model arbitrarily by just scaling up its size. Computation, number of parameters, size of data, data set in tandem. But then that means that your improvement is just due to brute force. So brute force wins. Once you have a transformer architecture, you don't need any clever tricks. You just stack more layers, run more computation on a greater data set, and you can pull down your loss as far as you want. So mathematization wins again. So that's a second phenomenon in the world of language models where I see mathematization to be highly successful. Okay, second paper I wanted to bring up for discussion is this one from 2022. Again, a strange phenomenon connected to scaling. In this paper, these authors purported to find emergent abilities in large language models. Right? Very curious result. And as I said, I'm taking all their observation and their analysis at face value. We can discuss that later if we want. So here are their results, right? So you're seeing 8 graphs. Each one of them represents some benchmark, which is a set of questions on some particular topic that you give to these different language models, and then you see how accurately they respond. Two things going on here. In each one of these graphs, you see that at the beginning, at the small scale, the model has 0 accuracy, or the accuracy equivalent to random guessing. But then as you grow the scale, as you grow the size of computation, data set, parameters, at some point, ability goes up. An ability which was not present at the beginning suddenly achieves 10%, 1 order of magnitude greater, climbs up further. So there's 2 things. One, an ability was not present at the beginning, is then present as you've scaled up. But 2, oddly enough, the shape of the learning curve here is not like a smooth line like that, right? In each one of these benchmarks, it looks like a step function. It's 0, suddenly abruptly climbing, right? Suddenly abruptly climbing. And the authors in this paper said, there's no mathematical explanation why it's occurring over here. Okay. So what are the implications I draw from this set of results? Well, if there are emergent properties, it seems clear that emergence is contingent on scaling up the size of the model, the amount of computation, and the amount of data. So again, brute force uncovers emergent, new, or hidden abilities. So once again, mathematization wins. So just to bring these 2 papers together, the first paper showed us the test loss, a measure of error, decreases predictably with scale. The second paper shows that accuracy on tasks increases or emerges with scale. Both phenomena expose LLMs to Husserl's mathematization critique by virtue of the scaling project. Clearly, the phenomenon of the LLM involves an operation of mathematization by design, just by virtue of how it deals with language. Additionally, in scaling phenomena, we see what seemed to be Husserl's target in his mathematization critique. So now, let's go back to Jeff's report of Husserl's position on mathematization. So I'm going to just take a couple of quotes from this paper from 2007, Phenomenology in Cognitive Science, Mathematizing Phenomenology by Jeff Yoshimi. I'm not going to dispute anything. I'm going to rely on it as a report of Husserl's position. I'm going to draw these two quotes. First quote. So this is Jeff reporting Husserl's position. Jeff writes, for Husserl, these transformations of mathematization represent an ontological inversion, a reversal of epistemic and philosophical priorities of the worst kind, one root of the crisis of modern man. As a report of Husserl's position, I think that's perfectly accurate. Undisputable, prima facie so. Second quote, Jeff goes on to say, but Husserl is here arguing against those who replace the real world with a mathematical world. None of what he, Husserl, says speaks against applications of mathematics to the real world. One need only distinguish the symbols used in mathematics from the real processes those symbols represent. As a report of Husserl's position, I think that is also accurate. Nothing to dispute there. I agree completely. I would say, though, that there's a third thing. There's like a third step, which I see in Husserl's crisis, which I would add to those two quotes from Jeff. As I read Husserl, Husserl says, true, we need only to distinguish the symbols from the real. But I also see him as saying that we can't, that in fact, we can't avoid replacing the real world with the mathematical world. So that actually, while Husserl says that math should not replace the real, he also argues, now we may disagree with him on this, but the historical Husserl seems to argue that the math is so successful that in fact it does replace the real for us. We can't help it. We have to, because math is successful and that is a good thing. Which is why he's able to say over and over again that although Galileo is the engine of the mathematization of nature, Galileo is not in any way making a mistake. He's a good scientist. So, success of the LLMs, their approach to language, as well as their scaling regimen, I suggest would be identified by Husserl as examples that fit his mathematization critique. He would probably, the historical Husserl at least, draw a connection between the LLMs and the broader cultural phenomenon of crisis. And this brings me back to what I said about Husserl at the beginning, which is I think Husserl is important to bring into this discussion because he doesn't just have a phenomenology of cognition, but he has a phenomenology of cognition that is embedded with a phenomenology of culture at the broadest macroscopic level. And we may disagree with that third and last component of Husserl's mathematization critique. And we may decide to disconnect that third position from the first two. But I think it's pretty clear that Husserl, the historical Husserl, would argue in the way that I think I've been able to reconstruct here. Okay, that's my last slide. Thank you for your attention. And now Jeff will take all of your questions. Just kidding. All right. So should I call on people? Let me see. I need to put this in gallery view so that I see everyone. Okay, top of the queue, I see Jeff. Go ahead.
Thanks, Hakhamanesh. I guess Susie's asking if you could stop screen sharing, first of all.
Okay.
Yeah, I really enjoyed that. And I guess I just wanted a kind of obvious response, which I think you have the resources to respond to, but I'd like to hear your response, would be that, contemporary AI and LLM researchers, and for that matter, historical AI researchers, understood that they were just making these tools, right? They didn't assume that all the vector mathematics and everything else was a description of the real life world. These are just tools that use math, but they're like, I mean, the thing Husserl, I take, was originally concerned about is like you read in a textbook sometimes, the world just is a mathematical manifold, right? Space-time is what's real, and space-time is some kind of structure that, Johannes could tell us about, and that's what's real. But, your everyday AI researcher isn't making that kind of claim. They're just saying, no, this is just this tool. So I assume it's some additional implicit claim that AI researchers and those that are impressed with AI research make, something like what we're getting out of these is real intelligence, or this is really what experience is vector mathematics, something like that. Am I kind of getting things right there?
Yeah, yeah. So the Husserl's view, right, is that we do this mathematization first with geometry. This shows us that we can achieve something like objectivity that overcomes the subjectivity of experience. Once we've gained that world of objectivity, since we want to have a justification for our belief that we live in one shared common world, we then throw out subjective experience and emphasize that mathematized objectivity so that, you know, sure, the AI researcher is totally aware that this is just a model, right? It's a model, right? In fact, the AI researcher doesn't even need to say that this is how the human brain works or how the human being processes language. It's just a way, it's just an engineered construct that is able to reproduce. Okay. But the Husserlian view is that the success of mathematized science gives us this objectivity, which then replaces our subjective experiences. Right. And so in our lives today, in a weird way, the student's decision to use the computer to write that program, as opposed to having the subjective experience of struggling with, Descartes and Heidegger to write their own Descartes and Heidegger paper, right, is something that I'm trying to maybe shed light on, right, as a cultural phenomenon that maybe Husserl had some input into, right? So I'm trying to really bring those two levels of analysis together, right? The cognitive level as embedded within a broader cultural phenomenon. That doesn't really answer completely your question, but that's how I would sort of suggest I'm coming at it.
Oh, that helps. Thank you, Manish.
Mike?
Oh, hi, thank you. Nice paper. I just I was struck by the graphics you show where at some point of complexity there's like this sharp, like sudden emergence, right? Yeah. And that to me was like reminiscent of just classic emergentism, right? Like, Samuel Alexander or, C.D. Broad or somebody who actually postulated that if you have sufficient organic biological complexity, like there's just sudden emergence of consciousness, right? But I take it that you're not talking about consciousness, you're talking about like development of like some kind of a semantic capability from nothing but syntactical rules or something like this,
Exactly,
or
exactly.
seeming semantic capability from nothing but syntactic complexity, right? Yeah. But
Right.
still, I want to say that the Husserlian view, unless I totally misunderstood, I don't think I did. I want to say that the Husserlian crisis view survives because what you're talking about emerging suddenly still isn't consciousness. So that's what winds up getting missed by the mathematical objectivist scientific reconstruction of the world, just as I still cannot account for emergence of consciousness. I'm not sympathetic to this kind of view by myself, but it seems like you can use this kind of view to maybe support or defend the crisis view in Husserl. Right. Thank you.
Right. So it's not the emergence of consciousness, but it is the emergence of certain abilities, right? Right. So those benchmarks are always very narrowly defined sets of questions on one specific particular kind of skill, right? So, for example, disambiguating pronoun references, right? I don't need to invoke consciousness to disambiguate pronoun references, but it's astonishing that at the beginning, the model can't do it, and then it can, right? Now, I should say, I just reported those results. That second paper is like highly debated and is a hot topic of debate for a couple of different reasons. Some of the authors have now written a second paper where they kind of retract their position, and they're saying it's true that these abilities are not there at zero, but then they are there, but it's actually not a step function. If we graph it differently, we might see a smooth development. And secondly, if the questions, if you think about like taking exams, right? You can have true false questions, but you can also have partial credit on questions, right? If you create benchmarks which give the model partial credit, in fact, it doesn't start as zero and stay at zero and then suddenly go up. If you give it questions that have a potential of gaining points on a smooth scale, on a continuous scale between 0 and 100, it seems like the learning curve is actually what you might be less surprised by, a smooth development, right? Another critique of that paper is that, well, it may just be that the skill emerges at that scale because you had leakage between your test data and your training data. In other words, set of a certain size, you're unavoidably scraping from the internet the kinds of topics that you're training on, that you're testing on, right? So you might just have fed the computer a bunch of examples of pronoun disambiguation once your data set size achieved a certain level. Okay, so these are just engineering features. Right? They're not really issues of philosophical debate, right? They have to do with how well they structure it. But I've just wanted to throw that back in the Q&A level. I'm not taking those results as absolute fact, right? The results are highly debated. But yeah, it's a separate matter than whether or not consciousness emerges. I agree with that completely. Yeah, thanks. David?
I'm on, yes, thanks. Great, really nice presentation. I'm just sitting back vaguely with my ancient mathematics background and gathering what large language models are doing, and also my son's a computer scientist and tells me how that works. Yeah. So one broad notion that I was beginning to hear but not set out was that what the mathematization does at its best indeed is useful, yes. Why? Because it sets kind of boundary conditions on what's going on within the boundaries. So we can still have our meaning inside these boundaries of basically not just syntactic, but you might think I'm thinking of a Deidegerian behavioral model as constraining the real thing without getting rid of it. So that's kind of a broad question, is how should we think about that? Otherwise, I like the presentation and the problem that's emerging from the papers that you were quoting from the OpenAI people. So meanwhile, next question, which given that, the familiar distinctions in logic between syntax, semantics, and pragmatics are still at play here, and that's nice, though I don't hear them in the discussion yet. Not your fault, but anywhere in the popular discussion. So historically, before I even encountered Husserl, I was reading Tarski, and I didn't know it. And Tarski's model of models was a model of intentionality, and I didn't know it. No one says that. I've written 2 or 3 articles, but who remembers them? I don't remember them myself, right? So Tarski's model of truth then, with Davidson's interpretation, brings meaning back in. Davidson famously, oh, is Ron McIntyre here? Ron and I started reading phenomenology after philosophy of the language with Donald Davidson, who was a master, of course. So Davidson wanted to get as much as you could out of Tarski type truth definitions for meaning. The truth definition was enough for meaning. Well, I think that's on the table here. No, it's not enough, but what are we doing as circumscribing the meaning? That's then where the mathematics actually comes in. So where do we get to truth? And the problem for AI and large language models and grading papers and so on is the truth is not part of the game. Meaning, as you're putting it very nicely, meaning constrained by a mathematical probability of how people are happening to use the words, a bit of Wittgenstein there and at work. Meaning is not identical with use. That's not even what Wittgenstein said. We know the meaning when we know the use. Now you can say we subjectively, by offering this as a development, you might say that we understand the meaning, we grasp the meaning in a subjective way as we get closer and closer to tracking viewing these, what the mathematics gives you is a kind of boundary conditions. And you can think, as you said at the beginning of classical versus the current generative models, the classical version has the constraints are very well defined. The later models for now are that no, there are norms in the sense of how do people happen to tend to use the words. So we get again this boundary condition I'm hearing on that, then we can go inside the boundaries now that with Husserl, grasp the meaning, and then going further with the epistemology that comes on the heels, you go into ideas one or logical investigations. You start in effect with the syntax, you go through the ontology, then you get to the epistemology, then you get to truth, or to the best we can get at truth, bit of pragmatism coming in there. So I wanted to know a little more about, it always drives me nuts when people wonder why the AI programs are getting ridiculous results, because they're not after truth, they're after the way people have talked, given and used the word for thousands of years, without regard to whether you're trying to track something like truth. So that seems to be a popular problem. So what do you think about truth, and thus, how does that fold into how Husserl is responding to mathematization?
So actually, a bunch of stuff to say there.
Too much, I'm sorry.
This is awesome. This is exactly what I was hoping for, just a wide discussion. Look, at UCI, I was taught that colorless green ideas sleep furiously shows that meaning is not derived from grammar. It's not syntactical, right? But now it seems that if I have a data set that has enough such sentences, right? Colorless green ideas sleep furiously. I don't know. Circular squares swim across the lawn happily and such, that I could train weights on a set that's like that. And I could produce something like semantical content out of nonsense.
Can I throw in a joke?
Yeah.
So how's that disinformation working for you on the election?
Right? Right. So there's the crisis aspect. There's that sociological crisis aspect, right? So that's one weird thing, right? Now I constrain, well, okay. I appreciate the language of use and the pragmatic thing, right? Because that's what the data set is. It's just all the language that people have used up to now that's scraped off of the internet. And I'm training my weights on, like a history of the use of English. So that means I'm deriving my semantical space from syntactical patterns in people's uses of the language, right? So then that exposes me to certain flaws, right? That exposes me to all the errant patterns of human speech and human writing. And so when people say the model is hallucinating, right? It's not really hallucinating, right? It's not in any way an error. It's doing what it's supposed to do. It's just the data set informed it in this particular way, right? So its illusory responses are exactly what it's supposed to be producing. And that's because, as most of these textbook deep learning tell you at the very beginning, this gets back to the truth issue, they always tell you, remember, whatever the computer says, it doesn't understand what it's saying. It's just saying. It doesn't have any reference to the real world. None of the output is pointing to any object out there, right? It's just purely internal relationships among these tokens, these words and parts of words and so on and so forth. So the question of truth, if it's related to the question of the real world, of what is the case, is completely out of the ambit of a large language model. Right? And so we may be happy with that, we may be unhappy with that. It may be that maybe we don't need that question anymore.
Now, what about Rorty's response?
Which was?
Truth is what they'll let you say.
Right.
That doesn't help with the science or the mathematization. So the model is, again, as you're saying, exactly right. At most they're constrained on meaning, which is very interesting indeed. So I think it's really cool. But then you're not going to get truth unless you're giving more and more weights to the experts, which is politically off the table as of yesterday or 2 days ago, 3 days ago. So that's very interesting. Of course, I'm being a little more realist than perhaps a flavor of a phenomenologist, whether Husserlian or Heideggerian or beyond, will take, right? So thanks. This is all great stuff. Thanks so much for the good work.
Thank you. Terry?
Yeah, thanks so much. I really enjoy this discussion, and the presentation is super helpful. And I'm sort of an ignoramus around a bunch of this, although I have made some strategic decisions in teaching, including that I am now requiring my students to have a dialogue with the AI before they turn in their paper, and to think about what plagiarism is and isn't in light of that dialogue. But I have just a question to be sure I understand. In thinking about the crisis, the text, the notion that the subjectivity is cultural here, that is at risk, that the stakes are our subjectivity, and it's cultural. That means we're not just talking about individual subjective experience, right?
Okay. Yeah.
Okay. So, and I'm thinking about the Galileo thing. So part of the critique is that we actually become what the mathematized version of the world needs for us to be. And that's not something that is from large language models. I don't do very well reading sundials.
Right.
My students are even unaware that there is a sundial on campus right outside the building where our classroom is. And I don't know if they know what a sundial is. And certainly a lot of them have difficulty with analog clocks, right? So in a way, the crisis question is about a process that changes, dare I say it, human nature. What abilities we come to have are in a relationship with what abilities our technology comes to have. And so when David wonderfully gets us back to Tarski and Davidson, the problem that we may be losing truth for real, that it's no joke that we're in truthiness, right? That problem is not in this discussion, really, right? Or else it is that something important about the boundary between syntax and semantics has actually been breached. And breached in the dramatic way in which the boundary between fact and value or something got breached, right? So
I agree completely with your characterization. You're absolutely right. And I think that both Husserl and Heidegger, when they talk about science and scientific practice, unlike a lot of people who sort of misinterpreted it, they're not criticizing science and technology for producing this. They're affirming that science and technology need to do this to be successful. Because, we don't want the plane to fall out of the sky. We want the plane to fly. When I'm in the plane, I want maximum mathematization, and I want it to be totally objective and utterly reduce subjective experience. However, there's a place there for philosophical reflection to then enter and to interact with the scientist and the technologist. Husserl says specifically that, the practitioner of mathematics can't reflect on the life world when he or she is doing the mathematics. It interferes. The skill of the mathematician is an abstraction, right? But there's a space there, or there's an opportunity there for the philosophical phenomenologist or the phenomenological philosopher to come in and to redress this problem. Right? I think Husserl kind of is making an opening for people to interact with the science, right?
So if we say that in the LLMs, it's actually the syntax actually at scale grasps meaning. Now we need to know what we mean by grasp. And there we are back at the very beginning of our conversation about what it means to grasp a concept. So, so one question that arises is whether the normative, David said Rorty's slogan, there's a problem there. What you can get away with saying, what they let you get away with, who's the they, right? Where does the normative cultural, I'm going to call it zeitgeist because that's where we are now. We have a different, from what we had in my childhood anyway, normative world, and do we expect the norms themselves to also be emergent somehow, that the practices that the technology installs in us will somehow generate its own what you can get away with and what you can't get away with?
Yeah. So, right. So there are the optimists who will say that the technology will build our way out of this. Right? There are the optimists who say that, the technology will solve climate change. That the technology will solve the problems of mathematization, right? And then there are the metaphysicians like me who say that, no, actually, there needs to be some completely different thing. There needs to be qualitative experience that's not quantifiable, that's kind of brought face to face with these systems, right? But zeitgeist, sure, right? At that cultural level, at that macro level that Husserl describes, in the opening pages of Crisis, right? We are definitely there, right? That's definitely occurring. And we're definitely heading down that, at a greater speed than we were during his time, perhaps even. Right? I know that I'm not really answering questions, but I was just hoping to create exactly this kind of discussion here, right?
Makes me want to recommend a novel from the same world as The Crisis, which is Leon Feuchtwanger's novel, The Oppermans, which tells the story of a Berlin extended Jewish family as the Nazis' rise to power comes to mean what it comes to mean.
The Offermans? What was it?
Opperman, I'll put it in the
Oppermans, okay.
I'll put it in the chat. Right.
Ron?
Yes. I haven't formulated such an argument yet, but couldn't something like the Chinese room argument be applied here? I could have access to all of that data, and I could predict exactly what a Chinese speaker would say in a certain in pretty much any circumstances, but I still wouldn't know a word of Chinese. So the question is, what do I have access that that the mathematization is not capturing?
So what I'm suggesting is that it may be that all we need is to be able to predict the next token. All I need is to be able to manipulate those symbols of Chinese without actually understanding Chinese.
Need for what?
To produce the next coherent English sentence or the next coherent Chinese sentence. Remember, I said at the beginning that the program is only designed to produce a coherent sentence based on a previously input coherent sentence, right?
Okay.
So I may not need to know the meaning of Chinese to be able to just produce coherent Chinese. I may not need to understand English to just be able to produce coherent English, right? Which
Well,
is
the same thing is true of using a calculator.
sure.
A person who can use just simple addition and subtraction can use a calculator and determine it, but not be able to answer, a first grade question.
Right, right. And so we have these technological tools which allow us to achieve certain tasks without having the understanding that we used to have when we didn't have that tool. So now we have that for language. And all these tasks in our lives that are linguistic seem to now be satisfied by this tool, right? When I was an undergrad, this guy, Stephen Wolfram, came out with this program called Mathematica. It was basically doing for calculus and college math the sorts of things that the language models do for the students today in English. Like it could do, it could plot a three-dimensional polynomial. It could do a surface integral. It could do all my calculus homework, my linear algebra homework, etc. And it could do it without me having the understanding of what's going on at all. I would just input my homework problem and it would produce the result. Now, that I still learned to do that stuff despite that tool just had to do with the fact that I wanted to have that understanding of what's going on, right? My students who use this tool to generate their homework papers are choosing that they don't need the understanding. They just need to achieve some linguistic task, right? They're the kids who are just using the calculator to do the homework without thinking about what it is that they're doing. In a way, it's just a scaled up version of the calculator. It's like a calculator for linguistic tasks as opposed to numerical tasks. And it points out to bring it back to the Chinese room argument, to just get an answer, to just get an output, I don't need the understanding, right? Just like the junior high school kid could do their junior high school math homework assignment without understanding what's going on. Now, as these kinds of tools cover more of our life world and we can do more of our everyday tasks, mathematical, now linguistic tasks, we start to lose something. We lose that understanding that we used to have. And I'm saying that's the phenomenon that's described by Husserl at that broad level of crisis. Right? That's that phenomenon of losing of meaning, of losing of value, losing of the relationship to the real world.
Right.
Does that help?
Yeah, on that last point, I think that's pretty much the crux of the crisis for Husserl. And then we become satisfied with that, and we think, well, that's all there is. What we were talking about before, understanding, meaning, all of that, that was just some sort of fantasy tale we were telling. And Husserl disagrees with that, right?
Right, right. As I see it, Husserl says, okay, now if that's occurred, and that's the crisis, now the phenomenologist needs to come in and develop something like a phenomenologically grounded objectivity as alternative to that purely mathematically justified objectivity.
Okay.
Because then you have that kind of objectivity, but with meaning, with value, with significance, with the relationship to the real world.
Okay, that helps.
Right? David?
Yeah, I'm having trouble getting my computer to raise my hand, so I raise my real hand. Another example of the same thing, I guess. A feature of the crisis which has been emphasized by first Maria Hartimo in a book, Husserl and Mathematics, and then by Stella Moon, who finished a dissertation a year or so ago. Husserl emphasizes the notion of a community of empathy. Gesellschaft, I'm messing up the pronunciation. And the idea there is that this actually gets back to the point about truth, because if you're not tracking the experts, you're not getting toward the truth by epistemic means. So the idea of the community of empathy was that as you develop as a mathematician, and so I guess you and I can talk about this, and Stella if you do a lot more mathematics, you have to get into the subjectivity of that we are sharing, which is understanding. So the mere boundary conditions don't enable you to progress into the actual practice of mathematics itself. So on the horizon, technical and metaphorical use, on the horizon of Husserl's argument is his own experience with mathematics. So apparently he was not a great mathematician, but he did a hell of a lot of it with a dissertation. So the point is that you get amongst in the community of experts, you have a community of empathy, which involves understanding what I'm doing and what the others are doing. But you have to work your way into that community of mathematicians in order to have that understanding. So then we're again holding out, maybe you want to call this understanding more social or intersubjective than subjective. And then you have open up a lot of doors that way. But the point is that there's still a kind of, call it a Husserlian resistance to, I think of it as the hard problem of consciousness. There's something in the phenomenal experience of understanding how a theorem works. So I've forgotten, I've totally forgotten how the Pythagorean theorem is proved, right? That was so long ago, right? But there's something in the actual experience that is left out deliberately in the way Hakhamanesh is putting the AI model. The sanguine engineer, software engineer, knows perfectly well that there's something left out. That's not the point. The point is, how well does it work for computational purposes? So back to community of empathy. Application.
Yeah, that's actually a very good point, right? So sometimes you think reading Husserl's analysis of mathematization as if this were just a formal process that could have almost unfolded by itself. But that's actually not Husserl's point. There is this community of scientists, and there's this whole analysis of how scientists interact. And that's all that stuff in that other essay, Origin of Geometry, which is at the end of the Crisis book, which talks about how there's a sort of genetic phenomenology of how a science, a Wissenschaft in the general German sense of it, develops not just as a mechanical process, but as based on a community of subjects participating in something, right? In these ideal objectivities that are constituted based on this thing about writing and so on and so forth. Yeah, but yeah, thank you for bringing that up. Yeah, there's a community of scientists that shares a kind of subjective experience of mathematics as well.
Susie is a practitioner of empathy.
Yeah, I mean, I'm sorry, here it's very noisy outside, but it's it's quite a problem to see how this can fit there's no body. That's the biggest problem, right? And so the perceptive pairing that generally starts automatically in an empathetic connection, which is generally the first step, is missing. But I don't think it's impossible, nevertheless, through collection of data, but not embodied.
Well, so the hardcore practitioners will say, all you have to do is embed, tokenize, embed, and start adjusting weights, that everything is modelizable, that the deep learning revolution is just telling us, as long as you have enough data on any phenomenon, you can adjust the weights that will predict the outcome. Right? I think, there's this very famous textbook on AI by Russell and Norvig, and somewhere at the beginning they say, it doesn't matter why people do the things they do. All we care about is that we have data showing us that they do it this way. And someone else from UCI, actually, my old friend, Hermano Benchivenga, wrote a paper about this many years ago, criticizing this view from a sort of this very rich Kantian perspective, saying that, well, the pure data, just intuition without concepts, that's not knowledge. Right? A classically Kantian move, right? That I need to have concepts, whereas these AI guys are saying, you don't need the concepts. All you need is lots of data. Those guys would say, if I just have lots and lots of data on corporeality, on lived body experiences, I can model that too. We're not there, but the fact that they're so successful with language, it has just been very, very scary, I think.
I mean, there are apps now that use a machine learning technique to provide therapeutic support to clients. To have fun, I used it, and I don't wish to have that kind of therapist yet. But it's interesting. I mean, yeah, they started with the machine learning platform.
Yeah.
Susie, I guess you've designated me stand-in moderator. I'm not sure, does anything need to happen now that noon has passed? Or we just keep going? Yeah.
Yeah, there's one more question from Clinton. Generally, we are 1 hour and a half on average.
Okay.
Yeah, I'll keep mine short. Just thanks, great presentation and really nice discussion of how to incorporate some of the Husserl apparatus to raise pointed questions about what's even happening. So I really appreciate, I like the direction of it too. I guess just on the thing that might be, some of the many things that might be at issue, if the question about which term to use to describe what is happening in the activity that's being displayed and churning underneath the display, should it be called intelligence or not? Does it have a kind of cognitive capacity unto itself, or is something else going on? And then to the extent that we want to think, maybe that is all there is to fill in the blank, whatever we use the label for. So I think, a lot of the questions that we're talking through is as much like, well, that all there is point, we're just wondering, like, there's some gap there and we're trying to figure out how to talk about it in different ways. I guess one thing that I was wondering about in relation to the gap, you were alluding to the Benchivenga or Kantian, or I don't know, these like more spiritualist points of view. If you were thinking about the intelligence as not just data, but transforming data into information and organizing. And so it has the concept part, at least. And then the display of it is at least a display that can also display, what would have been communication of feeling, and also in that way, display some kind of interaction that has to do with feeling. And so if you're like, it can display truths, and it can also display pathetic responses, including empathetic responses. And, as Susie was bringing up, the interactivity with apps in relation to mental health is like off the charts as far as sales. So, we're like, okay, cognition, the faculty of cognition, the faculty of feeling, and their displays, that's interesting. The one thing that I was wondering about the third faculty of the spirit or whatever is the faculty of choice and action. And I know that for many people is the most troubling, not that people could interact cognitively with it and feel like there's no loss, or interact empathetically or through feeling with it and feel like there's no loss, at least within some ranges, but that the it that's doing this would actually decide and act. And that it would, and thinking in that level, not just about cognitive intelligence or affective intelligence, but practical intelligence, and not just intelligence, but action, like execution. Do you have you interacted with any of the theorizing from the inside, or whatever, the OpenAI type inside, on artificial intelligence operationalized or as executors, and agency in that particular, not just the, turning it on and the algorithm is activating, spitting out that sense of act, but like where there's decision and practical, in a different sense, consequences about, have you explored that dimension at all?
Yes. So that's a whole subspecialization, which, interestingly enough, there are two companies that are approaching this very differently. The OpenAI people do what is called reinforcement learning through human feedback. So you train the decision of the model by showing it what human beings would do in these kinds of situations of decision. Their big rival, Anthropic, is training their models to do decisions based on synthetic data. So the OpenAI people hire human beings, present them situations, and have the human being write up the response of how they would act. The Anthropic people use a computer to generate situations and reactions to those situations, and then train this computer to imitate that computer. Right? So that's the difference between two ways of fine-tuning it. These are also ways in which they've tried to eliminate the whole hallucination problem, right? So you train a much larger model that just produces synthetic data to train for decisions, or you have actual human beings educating it, essentially, right? Two divergent research projects, right? But these also link up to the field of reinforcement learning in psychology and so on, right? There are very important additional dimensions of it that I'm completely not talking about here today, right?
Yeah,
but then
sorry, go ahead.
Ethical. Sorry, that's where this whole ethical axiological dimension then is attacked by these different research projects.
Yeah, I mean, just on that last point, not so much again that it would display something you could interact with as if decision, but that there would be, I think you were alluding to this with like the not just embedding it to then be responding in some way cognitively or empathetically through apps, but that it would somehow get keys to actually affect in the world in at some other more concrete level, the embodiment in that sense of the agency. So not does it get decisions right, but like are its decisions executed in real time, like with bombs or with the power grid, or decisions about who gets healthcare, and that like it actually executes it, doesn't just give a display of like these are what we recommend or whatever. But and yeah, on that, the three dimensions, are there similar kinds of like I mean, does it all just funnel through the cognitive graphing, or are there similar kinds of graphings about decisions and scale, or is it like there's no separate kind of research about the scaling questions on the decision and feeling display? It all goes through the cognition, or that was where I was going with the question eventually, but
I see what you mean. Okay, so the scaling phenomenon is purely seen for language. Right? And in fact, there's some people who are starting to say that actually that observation seemed to be skewed by our analysis of English, and that the scaling curves for Chinese don't look like this at all. That's really weird, because we've known for a while that the vector embeddings are interlinguistic. The relationships between king and queen work out the same way arithmetically between Chinese, French, German, Italian, and English. However, the test loss doesn't drop in the same way in these other languages that it does in English. Now, whether or not these other dimensions of experience can be mapped onto the cognitive and processed as a cognitive problem, right? So as long as we're thinking about a transformer, a GPT, then yeah, it's being translated into a cognitive model. Okay? Of course, the transformer is just a thing that's super popular right now. There are a million different architectures. Right? There are convolutional nets, there are RNNs, CNNs, trees, et cetera, et cetera. This is just something that's been extremely successful with linguistic output. And it's drawing all these resources. There's a huge split, right? There's this big AI scientist from France by the name of Yann LeCun who says that, these models have achieved less intelligence than what an orangutan can display. And that we're going to have something completely different from transformers to have actual intelligence. And there are these other people, the OpenAI and Anthropic people, who seem to say, no, you just have to tokenize everything and then train weights on it, and that will solve everything. So a cognitive reductionism. There are various different schools and research projects.
Susie, I feel like your connection is pretty good if you want to take over.
I feel self-conscious because there are so many cars passing by. But I mean, thank you for this very important talk. We are going to face this sooner or later. I don't know if there are more questions or if you want to make a final comment to your presentation.
David?
Oh, just to follow up on Clinton's point. I've been tracking forget the word because it's in the business. I've been following the phenomenal intentionality work for a long time. And the idea that there is a kind of cognitive intentionality is different from cognitive intentionality. So the assumption would be, perhaps, that even the experience of volition, and that actually takes us back to Husserl on action as opposed to the Chinese room. The idea would be that there is a phenomenal character of volition, not the cognitive, here's what to do, but the volition, and that's what you were talking about. Execute, go, do it. And that would be another feature of what's left out, but may still be circumscribed by the rules. So I gather, as Hakhamanesh is suggesting, because I only hear trickle down ideas from what's going on in the AI world. I always keep wondering what AI means, and you were already setting that aside. So yeah, there's something about the phenomenal character of perception, of embodiment, of cognition, and the rationality side, the purely Kantian part. And then you bring in again Merleau-Ponty and on the heels of Husserl and Sartre going on with volition. And the phenomenal character of this doing is arguably, again, part of what's left out, part of the hard problem of consciousness, volition, phenomenal volitional execution. So just a comment to put that in a larger context. Cool stuff.
So let me just throw into this the notion that that point or a version of it is already in Brentano. Being ready to do the critique of the primacy of the cognitive over the conative, this notion that we are, distorting our account. Certainly when we think about consciousness, we're distorting our account if we keep in second-class citizenship the feelings and the strivings.
Did you say Brentano?
I think it's already in Brentano.
Yeah, the whole point of inner consciousness is at work, whether you like it his way or another way.
Right.
Very cool.
And it's really, I mean, for Brentano, it comes from Aristotle. That there isn't engaged reasoning that isn't actually practical reasoning.
Cool. And then we want to move into the Asian languages and the Asian philosophies that address them. So, yeah.
I think everyone on this call should just write about AI. Bring these perspectives into these discussions. These are these perspectives that are missing.
It
Let's
is
hear
time,
Aristotle and GPT.
right?
So we have to get all of these perspectives in there within the next 3 weeks.
Yeah.
Yeah.
Thank you, everyone. It was really good to see all of you and to talk about AI. And thank you for this wonderful presentation.
Thanks,
Thank
everyone.
you. Good to see you all.
See you next month.
Next month.
Bye, everyone.